Hello and welcome to the latest Landor LINKS Green Transport Recovery webinar series, and today's topic is data discoverability for transport planners. I'm Paul Jackson from Traxis and I'll be chairing this session. I'm delighted to introduce our speakers this morning, who are Darren Capes, Gaurav Reen, Graham Scott, Philippe Perret and Janjeev Jong. Each speaker will present for about 8 minutes and we'll have a Q&A panel session once all the speakers have finished. I'm sure there'll be lots and lots of questions given this topic. So if you have a question for one of the panelists, please can you enter it into the question box, which you should be able to see on your screen. And then I will take those at the end of the session to the whole panel. I'd now like to hand over to Darren, who is going to talk about how the DfT have accessed and used data to monitor activity during the current pandemic. Thank you, Darren.
Thank you, Paul. Thank you. To the next slide, please. So my name is Darren Capes. I'm ITS policy lead with the Department of Transport. My day job is thinking about connected intelligent transport systems policy, and particularly thinking about how we ensure local authorities meet the challenges and help us deliver connected technology, connected vehicles, and ultimately automated vehicles, and what policy interventions and what technology interventions we need to make as government to support that. That means in my day job I work closely with local authorities, and one of the other things I do in my day job is I manage the Transport Technology Forum, which is, for those of you that don't know, is a forum sponsored by government. It's an open free space for government, local authorities, suppliers to come together and talk about technology, talk about lessons, talk about learning, talk about experiences, and be part of this aim to push connected technologies forward. What this means is that, as I said, I have a very good understanding of local authorities. I have a good understanding of who's doing what local authorities are doing, how local authorities work, what their capabilities are. And this became very important in the recent in the recent challenges around COVID. Take the next slide, please. So, as we know, COVID-19 has been an unprecedented event which has affected every element of society, and it's been very important for us to understand, as the department, it's been very important to understand what's going on out there, how the initial lockdown affected the country, how travel and behaviour patterns changed, how patterns and behaviours have changed as lockdown's been eased and different measures have been released and implemented, and what effect that's had on transport in the country. And that's important for two reasons. It's important because it gives us a clear understanding. It's sort of like a temperature gauge. It gives us an understanding of what's happening out there. It's also important in the longer term that we study the effect that lockdown has had, the effect that COVID has had, and how we respond from that. And we have a wealth of data to be able to do that. We have a wealth of data on the strategic road network and in London. We have data across the motorway network, but we have very little data in terms of what's happening on local authority roads, what's happening in terms of cycling, parking, and freight. Basically, beyond our existing data network, which has performed extremely well where it can, we have huge gaps in data that we generally in the past don't have access to. So working with the TTF, we put out a call for local authorities to help us and local authorities to start to provide data. And this has been hugely interesting because it's shown a light on what data authorities have, often data that they don't fully understand the implications of or the potential of, and it's shown where data is, where data isn't. It's shown what local authorities can do, where support is needed. It's been hugely informative in terms of understanding local authority transport data. And we've been working with ARUP to standardize and consolidate data into a single tool, a single data source, and a single data dashboard and a set of reports that now give us a much clearer understanding nationally of what's happening on local roads and in towns and cities across the UK, across England particularly, than we've ever had before. And this is growing and expanding. It's now invaluable to DfT. Those of you that watch the nightly briefings on the BBC that ran until about a month ago will have seen that transport data was pretty much always the first slide that was shown. That's how important it is to government. And this data has been part of that wider understanding of the data landscape and what's happening out there. Having built an extremely useful resource, it's now important that we don't lose that. It's important that we understand the benefits of having that resource. It's about ensuring that we are able to provide local authorities support to ensure that they're improve their capabilities, that they start to see the value of the data that they maybe hadn't seen in the past, and that we continue to grow and use this as a national resource and a national part of how we plan and understand the road network. So can next slide, please. So in terms of numbers, we've had around 40 local authorities participating, slightly more than that. Now that doesn't sound like a great amount when you think there are 152 highway authorities in England, but it's a great spread of authorities, and we had some real quite large authorities in there, so we've quite a lot of sites. So we've had over 6,000 different sensors contributing to the database, contributing to the work that Arab have been doing to amalgamate this into a common data source and to build some common functionality around it. And at the moment, we've processed over 16 million records, and that's in about 3 months, and that's growing all the time as we expand the data that we're using, and we bring in data from not just from traffic sensors, and that's the core of the data. It's about traffic sensors, but bringing data from car park counters and machines, bringing data from other suppliers such as Vivacity and Inrix, who are able to bring us data based on analysing CCTV images and using vehicle tracking software, bringing data from cycle counters and from bodies such as the Canals and Rivers Trust to bring a really wide understanding of travel, particularly in urban areas, but most definitely away from the core network that DFT traditionally counts on. Next slide, please. So the graph you can see there shows us, the picture you can see there shows a spread of the data. As you can see, it's spread quite widely, but not widely enough. There's a challenge to continue to grow that, but we currently have a good understanding of data across the various regions of the UK. And as you can see, of England rather, as you can see, there's a great spread there between traffic data and cycling data. So again, cycling data particularly is something that we had very little of until this. So this is a really new resource that we're mining for the department. It's a really new source for government and for a wider understanding of what's happening in cycling. So that's absolutely invaluable. So the data that we're getting has been reviewed and is being built to DFT's data requirements. Now, as you can imagine, being a government department, we have our analysts, our evaluators have fairly strict requirements about the validity and usefulness of data, and we've been able to meet those requirements. So we've been able to produce a high quality usable data set from local authority data, and we're starting to now script that. So we're starting to now build ways of automating the process. At the moment, there's quite a lot of manual intervention. There's quite a lot of work to be done to build that data into a set, but we're working to automate that at the moment. And we're engaging with local authorities to help them provide data in the right format for us and help them, where necessary, tinker and alter their outputs to allow them to be suitable for our use, to allow us to be able to consume that. And we're now starting to share that data in flat file format. We're now starting to build APIs to allow us to share that data. We're now starting to think about what this looks like as an ongoing national data resource. Take the next slide, please. So today we are producing very interesting graphs. There is a website link which I'll give you at the end of the presentation to a page on the Transport Technology Forum website. We produce a weekly digest which contains a number of standard graphs, such as the one you can see there, which is hugely interesting. It shows some really interesting things about how traffic has performed through the COVID crisis, and you can see something. You can see a graph there which shows something which I'm sure is what you'd expect. Traffic fell off a cliff. It then came back again, but within that we can see certain nuances around what happened over the bank holidays, what happened as lockdown was eased. We get a really good picture of what's happening there, and I think going forward, certainly for the next few months or years or however long the effects of COVID are with us, this data will continue to provide a really useful understanding of what's actually happening out there as measures are implemented and removed. And I think that's important. And as this data grows, that richness of data just improves. So this is being produced as a weekly digest, which is available for everybody. We are also now starting to think about how we can feed that back into local authorities, how we can feed the data they give us in a raw format back to them as intelligence, and how we can broaden its use and broaden its utility within government and outside of government as well. Next slide, please. So what benefits are we seeing today? Well, we have more detailed data. We have more data across more of the country, covering a wider range of modes than we've ever had before, and that's allowing us to do things in the short term in terms of understanding COVID. It also acts as a great tool in terms of policy and interventions going forward. We've just released a national cycling and walking strategy, which some of you may have seen, which has some fairly major policy implications, some fairly major changes in legislation built into it. The fact that we now have a better source of data around cycling and walking than we've ever had is a huge asset. It's a huge contributor to how successful that strategy will be. We're also starting to build standard data structures, and this is very interesting because in some areas they've never existed before, probably because people have never needed to think about data across boundaries and across an entire country before. But this means that this builds into the wider government aim to build open standards around all sorts of data, to increasingly open up data. This is proving a real driver to do this in some areas of traffic counting and travel behaviour counting that we've never really thought about before. And we're starting to provide a single source of truth. We're starting to build, as I said, because we're now processing local authority data through the lens of DFT, through the standards that our data scientists and statisticians adhere to. We're producing a very high quality, very useful data set. And we're starting to see gaps in data and infrastructure as well. And again, this may lead to changes in the way that we fund things. It may lead to opportunities to fund local authorities. It may lead to opportunity to provide better guidance for local authorities and think about working across borders and working regionally, thinking about how the subnational national transport bodies and bodies such as Transport for the North can work to collate data across their areas to start to build a properly useful national infrastructure data set, which we have started. We are working towards that, but as the map of England showed a few slides ago, there are still gaps that we need to work on. Next, please. So we're now starting to think about what this service could become. So it was built in a hurry. It was built very much in a few weeks to help respond to COVID. It was very much about us using our links into local authorities, asking for help and getting a very good response, which was great to see. And it could end at that. We could at the end of this just turn it all off and say, well, that was great for the purpose of helping with the COVID response. Thank you and good night. But we don't want to do that because, as I said, I think we've more than proved the case that the data that we're collecting, the resource that we have in local authority data is hugely underused, and is a huge data set that could do an awful lot more than it is at the moment. And of course, local authorities are particularly interested in data for their own needs. So if you collect data from your UTC system, you want that data to run your UTC system. And at the front line, working as an engineer controlling the UTC system, you probably don't give too much thought about what else that data could be used for. Maybe other people in your authority do, maybe they don't. What this has done is started to get more people thinking about the wider use and benefits of their data, and certainly the wider uses and benefits of data as it becomes collated together into a bigger data set. So adding new data sets, setting standards for data format, transitioning away from proprietary to government and public owned data, building open data, and reducing commercial overheads for everybody, creating a service that's of value not just to DFT but wider government, both national and local, and the transport community in general. Our aims of this, improving the reliability through automated monitoring and reporting, so starting to build this into a process that can be run relatively cheaply as an ongoing service, but by more automation, again, makes it more likely to last, makes it more likely to be useful and usable in the future. And starting to build more ad hoc analysis, so we can start to do particular things with it. And obviously that was where this came from. This came from needing to do a particular thing, which is understand lockdown, understand COVID. In the future, this data set will be available to do new things and to understand implications of other policy interventions that we make going forward. Next slide, please. So thank you. That's a quick run through the work that we're doing at the moment, and we'll be expanding. The two website links there. The first link is the general link to the Transport Technology Forum, which if you haven't looked at already, I would encourage you to look at. We are now starting to produce reports around the work that we're doing. We are starting to produce guidance around this and around some other issues. So that website's updating quite regularly. The bottom link is a link to the page I showed on an earlier slide, which is the page where we publish the weekly data digest, from which you can see, from a set series of graphs, you can see how trends have changed over the weeks. And we publish stories of interest on that page as well, around things that people are doing around the data. So thank you very much. Thank you for the opportunity to speak to you. Please look at those websites. And if you are a local authority and you aren't involved in them at the moment, please get in touch with me at the DFT or through the TTF. We would love to talk to you about bringing your data and your resources into this project. Thank you very much. And I'd now like to pass back to Paul.
Thank you, Darren. That's fantastic. We've already got a few questions coming in. A couple of them actually you have answered through there, I think. So I'd now like to pass on to Garode to tell us about how Compass Informatics have used open source data to gain an insight into passenger experiences.
Thanks, Paul, and good morning, everyone. Paul, I guess when we discussed this webinar, we thought it might be of value to take a few minutes really to go through one particular platform, a Rate My Service, or Rate My Transport Service platform, which demonstrates, I suppose, the value of open data, and also through that, of course, just shows the value of how we can mix IT, GIS, analytics, mobile capabilities, and so forth. Needless to say, that reflects the Compass Informatics capabilities and the broader sort of Traxis capabilities. But it really is, the Rate My Service platform is a very good way of demonstrating the value in open data, in particular, the services that we can create out of that, but also then use that data to generate more data and to generate more insights from the combination of that data. So the Rate My Service platform is essentially around passenger engagement and getting their feedback on routes and services and so forth. The Rate My, just to note that the Rate My Service platform came through an EU-funded project, an Interreg funded project, really, which was focused on demonstrators around again, showing value of open data. And our one was sort of transport related. And the particular work we did was with Dublin City Council, but it's important to note that the platform actually, you can essentially swap in and out an RTPI feed, a real-time passenger information feed, GTFS standard, or whatever is appropriate, and essentially go. So it's sort of built to be applied and rolled out across many cities and regions and so forth. Dan, you might just, next one, please. So really, I suppose, if you look at all this, the word cloud here, really, I suppose for me, this summarizes Rate My Service. It's about being annoyed, it's about being afraid, it's about being positive, it's about having a friendly experience. It's about gathering information on public transport stops, on particular routes, on particular services, and so forth. So it's about all of those things, essentially about seeking, encouraging, generating passenger feedback on public transport, bus, rail, light rail, and so on, and generating information and information resource from that exercise of public engagement. And then also building a platform which is expandable into non-transport areas. Thanks, Dan. Next slide, please. Okay, and yeah, and the previous one, actually, let's jump ahead. Just while we're waiting for that, the Rate My Service is a platform, a web platform. Thanks, Dan, that's great. And at a high level, really, if you look at the bottom right, it's around taking open data sources. NAPTAN, for example, centralized, standardized resource around public transport stops. And then RTPI, which again, information on the particular schedules and services and so forth, again, be it in the general transit format spec and so forth. And all that data is taken and combined. We happen to use OpenStreetMap as well, but any other base data could be put in also. That data feeds into a mobile app where usability is important, and that collates all that information and allows the potential passenger to interact with all that information and see what is happening at the bus stop, when's the next bus, etc. But also allows that passenger to create feedback at the same time. That feedback comes back into a private portal, and the data is collated, again, the ability to generate insights, and also the important aspect of, for example, integrating that same data on feedback, for example, AVL data, that real-time sort of GPS-related data from the vehicles. Something we've done separately, but we can definitely see the opportunity to sort of amalgamate, integrate this data to create new sort of richness, if you like. Next. So I'll just, on the next slide now, I'll just show you a few screens to give you a sense of the mobile app in particular. and as you can sort of faintly see there, the user can get information about stops, about routes, about services. They can watch particular sort of their local bus stop, for example, and see how, for example, the services, the ratings are, if there's particular issues around local services and so forth. But in order to generate engagement from passengers, the first valuable thing is that this app provides information, schedule, when's the next bus due, and so forth, and what are the services at a particular stop. Next. Next there, Dan. Again, the mobile app allows us to look at a particular bus stop, for example, particular route, and to rate that by the stop, by the service that runs there, the particular service, let's say the 901 service on route XX, whatever, and then the general route. And once we're on the bus, we also tag time and so forth, so we can sort of essentially snap to particular services. What we don't get, and what we chose not to get, was any user information. So personal data just never arrives at us. And we can filter by operator and so forth. And as you can see on these screens here, then ease of use is very important, ease of feedback. You can see there's a range of categories there, but these are fully configurable. So it could be around the performance of a particular bus or service, but it could equally be about social nuisance and so forth. But actually, at the moment, we're also looking at doing a version of this which is focused particularly on accessibility, on universal design feedback and so forth. So again, that accessibility for those with mobility issues and so forth. So there's a full sort of configurability, if you like, about the platform. And next. Now, importantly, all of this data, as I mentioned, comes into a portal. And we can view the map-based patterns. We can visualize patterns of issues, positive, negative feedback, and so forth in the spatial context. But we can also look at it temporally, and we can also look at it and sort of drill down, if you like, to see particular issues around stops, around routes, around services. And like I noted, where I think there's great opportunity is to combine this data with, for example, AVL data. So we understand, and this will sort of mimic what we've done in another project for a transport operator, where we've looked at patterns from AVL data to identify issues around particular routes, and even where blockages are occurring in terms of particular junctions, for example, turns and so forth. So for example, if you get an issue around slowness coming up to a particular junction, a bus is stuck there for 10 minutes, you're going to see negative feedback and so forth. I think particularly in the context of obviously the instability of current transport provision, and we just simply don't know a lot of the time what is happening, the ability to get customer feedback in a very agile manner really offers huge potential to complement those one-off annual passenger surveys. And I think this is the critical thing. This is the real time, this is the more agile way of seeing what's happening out there, what's the customer experience, what's the passenger experience, and we combine that with a whole lot of other data. Philippe will be talking about mobile network data, with the fixed surveys stuff that Graham will talk about and so forth. So there's a great richness here in terms of integrating this data. Okay, next one, please. So I suppose just to note, talking here about transport, just to note that this firstly came from an interest in generating a bathing water app. So as an open water swimmer, what's the water quality like? What's the experience like at my local swimming location? So this is actually a transport app that came from a bathing water app, or Beach Watch as we were calling it. So it illustrates that we can push on into sort of non-transport areas as well, using the same framework essentially, and with some additional complexity if relevant in terms of integrating into other models and so on. Okay, and just next one then. I suppose it's important just to note that the same open data is also used in open trip planner stuff, journey planner stuff we're doing. So again, same open data used for customer feedback, used for journey planning and so forth. But similarly, we're a great opportunity for again, we're built from bathing, we're looking at transport, but why not use this to get feedback on other public services, but also importantly on private services which have public impact. That might be around Airbnb, for example, something that has an impact on housing availability and so forth. But again, a platform there ready to be reused. So important thing is we've open data here as a key enabler of generating further insights. Thanks. Hope that's been of interest. Thanks, Bob.
Thanks, Gerard. That's great. Could I now hand over to Graham to explain how Traxys are helping to provide access to historical data?
Yep, thanks, Paul. Good morning, everyone. I'm Graham Scott, and I'm the Data Solutions Consultant for Traxys, in particular the Traffic Data Services Division. I've been with Traxys since their acquisition of Sky High Technology in 2003, and overall I've worked in the industry for over 10 years. I started as a fresh-faced analyst, which seems like a lifetime ago now, and progressed through the company to my current role. Along the way, I've pretty much analysed all types of traffic data and introduced some new ideas that we still offer to this day. The theme of this webinar is data discoverability. For me, this is the polite way of asking, what do you have and can I have it? But it is hugely important to know what is out there and how to get access to it. We've seen over the last 10 to 20 years an explosion in the amount of data and the different methods we now use to collect it. And there's always been a need to understand what data is already in existence. And over the last few months, I think you'd agree that that's become much more relevant. Traxys collects transport data across the entire UK and Ireland for many public and private sector clients. This includes over 20 frameworks, TfL, TfGM, Transport Scotland, etc., and hundreds of other clients. Can I have the next slide, please? Over the last 3 years, we've received over 12,000 inquiries. What we class as an inquiry is a project level request to undertake a series of traffic surveys, and on average, each inquiry has around 10 unique site locations. This therefore equates to a potential database with over 120,000 unique survey locations across the whole of the UK. These unique locations will encompass a large variety of different collection methods that you'll all be likely familiar with: junction turning counts, CMPR, cycling movements. That standard list is pretty much endless. However, there are a few less well-known survey types, such as AI detection, path tracing, air quality sensors, and even recently social distancing monitoring. These inquiries, as we call them, are eventually categorized into either work that we have been commissioned to carry out, great, or work that we're not successful in winning. However, for all inquiries won or lost, we retain relevant information relating to the inquiry, such as the commissioning organisation, the survey types, and most importantly, the site locations and date ranges. This combined database results in what can be described as the single most comprehensive record of transport surveys in the UK. This database gives us a unique insight into the different surveys being commissioned across the country, whether we win them or not. And as a market leader in the data collection industry, we have sight of the vast majority of these inquiries on a daily basis. We've had access to this data for some time, and if you've recently inquired with us about historic data, then it's likely that one of our researchers will have used an internal system we've had in place to hunt down the data. However, in terms of data discoverability, we know what's out there, and we want to open that up to the industry. Can I have the next slide, please? We'll shortly be releasing our Conduit platform, which will give users access to this vast database and allow you to inquire with us directly. It will keep organisational and company information private. However, it will provide a new visibility in the industry to where projects have and are being undertaken at site level. Can I have the next slide, please? The idea is to create a platform which allows users to search for information about what traffic survey projects have been requested and undertaken across the UK. This can all be done on the web-based conduit system with the ability to filter on specific regions, survey types, and date ranges. Can I have the next slide? Users will be able to select single or multiple inquiries to add to an inquiry list, which will be as simple as clicking on a specific point or drawing a polygon around a specific area of interest. Can I have the next slide? Finally, users will be able to request the information about inquiries and availability of data and any costs or restrictions that may go with it. Traxys will research these inquiries and get in touch about what is available and be able to facilitate the data sharing between organisations. Can I have the next slide? So this is this platform is our stepping stone to changing the way our data is made accessible and discoverable. I've just discussed phase 1, which is data discoverability. Again, what do you have? Can I have it? It will become a great resource for understanding what data is already out there in our industry, and hopefully it will be a starting point for many professionals looking for existing data. It will also be a service that complements existing and upcoming data discoverability services such as NAPTAN and the National Access Point, and it will be continuously updated, and we will be looking at layering additional open source data to help improve data discoverability. Phase 1 will be hugely beneficial to users in understanding what data already exists in the industry and to be able to inquire quickly about its availability. However, we want to push further ahead, and we're already making progress on additional phases. So phase 2, organizational based reporting. To further increase data discoverability and access to data, we're looking at delivering our reports to clients through the Conduit platform, allowing those users who have commissioned work to see the exact locations and to download the data directly for themselves. This will still sit alongside the inquiries database, so it will allow users to overlay existing inquiries that could complement their current project or even future projects. We also want to welcome third-party data and reports to be accessible through the system. We don't want to limit this solely to reports and data specifically from Traxys. We see this as a further means of increasing data discoverability and providing quite a time-saving cost to the user. The next phase, phase 3, is data as a service, standardizing data sets, removing the kind of siloed nature of reports and essentially letting the data do the talking. Standardization can sometimes be tricky, and we don't intend to do this in isolation, so we will look to the industry to understand what standardization is already in place and where we can adopt it or help to further develop it. We'll be introducing analytical dashboards across multiple survey types, providing solutions to feeding data straight into traffic models or just needing quick insights. That type of on-the-fly analysis has huge cost and time benefits, especially when you're wanting a simple answer from something that can sometimes be complex data. So in closing, this is the Conduit platform we have built, which will open up our vast database of survey locations to the industry, just to provide further data discoverability and promote data sharing. We're planning on releasing phase 1 in September, with phases 2 and 3 following this year and next. And can I have the final slide? Anja, thank you again for taking the time to listen. And if you'd like to know more information, then please feel free to ask any questions or contact me directly. Thank you, and I'll hand back to Paul.
Thank you, Graham. Thanks very much. Keep things moving. Could I ask Philippe now to explain how CityLogic use mobile phone network data to gain an insight into travel patterns?
So good morning, everyone. My name is Philippe Farret. I am a technical director at CityLogic. And as Paul just introduced, we really focus on using mobile phone data to understand movements on transport operations. So could I have the next slide, please? So I think we all start to come to the conclusion that actually data is now everywhere. I mean, it's part of our mobile phones, it's in our cars, with all the tech that is being installed on the road network, would it be by Highways England, TfL, and so on and so forth, to really collect a lot of data and even user-based data, as Gary just demonstrated. However, if we move to the next slide, please. This data is collected in various forms with various techniques, various approaches. I mean, it goes from the simple clicker undertaking a survey to using rubber tube, to using ANPR or video AI analysis or big data. And all those sources of data are quite disparate. They measure different things, they measure different areas. They can be very narrow in their view, they can be very wide open in their view. So a very disparate view can actually come from all these different data sources. Next slide, please. So at CityLogic, looking at this, we decided to focus on the use of mobile phone data to understand people movements. We actually work with GDPR compliant anonymized data sets provided by mobile operators. We develop our algorithms to infer information from these data sets. What we are talking about here is really what we would call big data, as we've got lots of volumes of data coming to us at a very fast pace. And basically, we need to take that data as it comes, process it, and store critical, useful information for us to be able to make sense of it. One of the great benefits of mobile phone data, maybe against other technologies, such as potentially GPS and so on and so forth, is that we understand the sample we are dealing with quite well. And what that brings is the opportunity for us to follow a very large sample. I mean, we are talking 15, 20 million data points or devices which can be understood across a network which also covers the whole of the UK without any added infrastructure, and that's really critical. But also because we understand the sample size very well, we've got then the opportunity to actually expand that sample size of devices to actually being able to represent the full population. So what does that give us? Next slide, please. It actually gives us the opportunity to test and measure different things on a very consistent basis using the same data set. Using mobile phone data, we can extract origin destination information, we can extract journey time, we can get an idea of mode, we can get an idea of repeat patterns, we can try to understand link counts, and we also have information about home and work by doing long-term trend analysis. But the key thing is all of these different types of measurements can be done all on a consistent basis, using the same data set, meaning that when we look at one element, which might be origin destination, and we start to compare this with repeat patterns or occupancy at a specific location, all of this is done very consistently. Let's be very clear here. I said consistent. I didn't say absolutely precise. I didn't say absolutely accurate or without any bias. And that's very important to understand. And that's true of all data sets. All data sets have biases and inaccuracies that also need to be understood as part of the process. And this is where people like ourselves at CityLogic are very important to understand the strengths of weaknesses of the data. Next slide, please. So what's also very important to understand, and this is very true of big data, maybe not so true of the more classic type of data set for transport, but with big data, ultimately what you get is lots of numbers, lots of data coming at you, but actually the data itself is not that clear. It's just row of numbers. and primarily because those data sets were not generated specifically for the purpose of transport. They were generated for the purpose of communication, and actually what we are trying to use here is a byproduct of that process to try and understand transportation. So this is where we develop algorithms. We focus on validating the outputs of the algorithms against other data sets to generate that very consistent view that I've just described before. And that allows us to actually touch different elements of transportation or movements. It might be around urban planning, what we would call city analytics. It might be really around transportation, to transport analytics, specific to rail movements. Retail becomes quite interesting. And also what we call city gateway, which would be basically based on a series of portals on web data access, APIs, and so forth, that allow clients to actually make best use of the data we produce in a more graphical, visualized way so that the data can be consumed in an easy way. And I think that's also a very important role for us, because data in itself doesn't really tell you much. But it's really how the data is analyzed, looked at in a very longitudinal way that brings benefits. To give you concrete examples, for example, as part of COVID, we are currently looking at rail station occupancies to understand if we can keep social distancing around concourse. At the same time, we are looking at traffic volumes on specific corridors in a number of cities across the north, on trying to understand at the same time at the moment rail origin destination movements, stations to station movements, to help one of our major clients plan for better rail services. Next slide, please. So I think ultimately what I'm trying to say here is data, especially big data, is useful, but ultimately it's the analysis that is done on the data, on how the data is presented and visualized, that can really make the difference for our clients and for really understand transport. Paul, over to you.
Thank you very much. And finally, but not least, can I ask Yanji to describe some of the work that's been done by Connected Places Catapult to help improve this challenge of data discovery?
Yeah, thanks, Paul. I'm Yanji Dong. I'm a data scientist working for the Connected Places Catapult. So my background, I've started my career as a transport modeler, actually, working for engineering consultancies and TfL for about 5 years in total, mostly around the area of strategic modeling, major scheme economic appraisal and data analytics sort of thing. Then after that, I've spent another 5 years at the Center for Transport Studies at Imperial College, mostly around the area of e-mobility and transport demand modeling, and also doing a PhD in developing machine learning and deep learning models to resolve transport-related problems. So at Catapult, most of my work is around web and backend development to build data system, and also doing data discovery, predictive modeling, and natural language processing type of projects. So yeah, I've been using data, including open data, for a very long time. And for my presentation today, I'm going to talk about the challenges in data discoverability and some of the work we have done to address these issues. For those who are not familiar with us, we are a not-for-profit organization, partially funded by Innova UK, and we sort of sit in the middle between public and private sectors. So I think one of the main pain points for data analysts and anyone who uses data in general is probably to locate the data they need and make sense of it and evaluate whether it's trustworthy to use it or not. So the chart on the left on my screen, which is adopted from the FIRE principle for data publishing, so demonstrates, I think, some of the needs that have to be satisfied before analysis can be carried out on the data. I think traditionally data publishing has been provided by data catalog solutions. So this works fine, I think, when there are relatively small number of data sets. However, when the number of data sets increase, it's become increasingly difficult to identify the data need. And also a lot of the data were published without consistent naming conventions or without unique identifier, which means it's very difficult to assess and automate the data workflow. Hence, a lot of manual process have to be involved, which means it can introduce errors and slow down the whole project. In fact, I think there's a study showing that for data scientists, we probably spend like 80% of our time focusing on data access and data engineering sort of issues, and only like 20% on analysis and model building. So apart from that, I think there are also issues in the data infrastructure differences between rural and urban area. So in general, rural areas are much better equipped with sensors and devices that can produce a lot richer data than rural areas. So then the question is, how do we resolve this imbalance to also bring the benefits of the data to rural area residents? Last but not least, and we also have this challenge in upscaling the existing workforce to enable them to better use some of the emerging tools like Python in data analysis, or maybe new techniques like machine learning. Next slide, please. So in the next few slides, I'm going to discuss in a bit more detail about the tools and projects we have done to address some of the challenges mentioned in my last slide. So next slide, please. So the first tool is we have developed something called Tumblr to help us import, store, and visualize disparate open data. There is a video to tell you everything about this tool. So if you can play the video, please. Thanks.
Introducing Web Tombolo, developed by the Connected Places Catapult. Tombolo helps data specialists to format, connect, and share geospatial data. One of the most time-consuming challenges for data scientists when they're working on a place-based problem is collecting and cleaning lots of different data sets to create a holistic view of a place. Web Tombolo is a modular, purpose-built tool to help import, store, and visualize open, disparate, geospatial, and time series data. Using Tombolo, data scientists can choose from a range of existing data importers, or they can easily add new ones. They can automate data collection from a number of sources, such as Excel sheets or APIs, and from across a variety of domains, from air quality to road safety to econometrics. For other users, like urban planners, the tool can help them access different data layers relevant to the problems that they're trying to solve. Once the data has been imported, it can then be visualized on an interactive map, alongside a flexible plotting space to give a quick view of data quality and completeness. Time series data can be visualized in combination with geospatial data to give a place-based understanding of a problem. The mapping tool can be used to investigate more granular data too. You can zoom in to get a more detailed view of a particular region, or navigate to specific data points. If further interrogation is required, the data can be downloaded as a CSV file, or just as easily be accessed programmatically using Jupyter Notebooks or other integrated environments. This allows more specific modeling or analysis of the data to be completed. The modularity of Web Tombolo means it is easily extended for use on all sorts of problems and projects. Here at Connected Places Catapult, we use this tool ourselves, so less of our time is spent on data wrangling and more time is spent on value creating, insights, and automation. Like mapping the risk of social isolation, understanding what affects debt and the cost of living, and planning more environmentally sustainable urban places. We're constantly adding new data sources to the tool, So get in touch with our applied data and technology team to learn more.
Right, thanks for that. I should also add that another strength of the tool is that for static data, which are the data that don't change over time, you only import the data once. And for live data, for example, like the air quality data, that's something being published in real time. So the tool is automatically initiating importers at fixed intervals to make sure all the data are captured and stored. So it's very handy, for example, to quickly check, for example, the impact of lockdown on air quality in urban areas. So this app has been deployed to Amazon Web Services, and we are using that internally. Next slide, please. So we also initiate the data science fellowship program to place our data science fellows directly into local authorities to bring new perspectives, data sets, and analytical methodologies to a well-defined problem. So this year in total, we have 4 fellowship programs, including understanding the risk factors for falling into rent arrears with Council, and mapping modeling of social isolations with Buckinghamshire County Council, identifying job skill demand with Essex Council using publicly available data, and also the road condition trend analysis with Hertfordshire Council, which is shown here. I think this is a good example to show how we combine council-owned data with open data we identified. And using data science skills, we were able to reveal a lot of insights and helping Hertfordshire to understand, for example, the key factors that are contributing to the road surface deterioration from a large range of potential variables. We were also able to build a predictive model for them to better understand which road might need maintenance work in future based on historical data we've used to train the model. I think through those fellowship programs, we were able to upskill some of the existing technical team and stakeholders, and also trial the data science and subject matter expert collaboration model. And the feedback from the council was extremely positive. Next slide, please. So here I'm using 2 projects as example to talk about the work we have done to address the issues around challenges in data ecosystem for urban and rural areas, which are quite different. For urban areas, the data ecosystem is defined by a data-rich environment, as we know, and the challenge is probably around how to enrich different data sets by maybe fusing them together. So the work mentioned on this slide, demand modeling assessment through a network demonstrator. So we use mobile network data and enrich that by census data, national travel survey, and also public transport network data, including the routes, timetables, and price for bus and rail, to develop an agent-based multimodal transport model. So this model simulates travel demand and transport system behavior at the disaggregate level over a 24-hour period, and is able to provide much better insights on why, how, and when people travel, and any potential for new mobility services such as shared mobility and willingness to pay. We also have another project just started recently. It's called Assessing Sustainable Transport Solutions for Rural Mobility. So which look at the rural context where the situation is legacy data sets are present, but often outdated, and they do not reflect the current travel patterns from the users. Hence, the data enrichment is often difficult. So for this project, we plan to use our knowledge from the mobile network data to explore whether this data set can be used to represent travel patterns in a rural context to overcome the issue around lack of up-to-date data. Yeah, next slide, please. So I think this is the end of my presentation. Hope this is interesting. So please get in touch if you have any questions. I'm happy to share more materials or introduce you to my colleagues. So now hand over to Paul, please.
Thank you, Janji. If all our panelists could come back online with their video and microphones, please. We've got a number of questions. We've got 20 minutes, so we've got plenty of time, but there are a number of questions. Just while everyone's getting sorted out, can I ask a question of Landor? There's a question about having access to the slides from Dawn Hughes. Is that this is being recorded? So
yeah, it's being recorded and the video will be online later this afternoon. Everyone will be sent a link to watch the recording.
Okay, thank you. Right, so I've got a couple of common questions here for Darren. One from Chris Bucock and one from Mike Pete about accessing the data, and is the data available to consultants? So that's one for Darren.
It isn't yet, but it will be. We are, as I said, this has been a very urgent build, and so we are still maturing the offer, and we are still thinking about how we open the data up. But yes, the intention is that we ultimately open up the data. Initially, the data is opened up in a very process format, in that you can look at the reports, the graphs we produce in the weekly report. But yes, the ultimate aim is that we use this as an available resource to all. And
sort of going on from that, question from Paul Everson is, will the data sets used by the DFT eventually encompass public transport as well? And linked to that, there's a question from Gareth Elphick about car occupancy data. So under COVID-19, there's a possibility the impact of social distancing will be affecting car occupancy. So is that something the DFT are looking at? And sorry, before you answer that, that's possibly a question to Philippe as well, because it came up towards the end of your presentation. So it might be a question about car occupancy from a technical perspective for mobile phone data. But if Darren could take those two questions first.
Yeah, okay, well, that's interesting to hear. And I think there is a conversation for us to have in terms of what data people want. As I'm sure you're aware, the government has spent an awful lot on research over the last few months and has set up an awful lot of projects doing different things in terms of data collection and analysis. I'm not personally involved in public transport data, but I know people who are. I know that we're collecting existing data. I know we're looking at vehicle occupancy and distancing on buses and trams and tubes and so on and so forth. There are a huge number of projects across government that are producing similar data sets or complementary data sets. And I think one of the things we will do as we move out of this initial phase is we will start to audit that, and we'll start to think what's useful, and we'll start to think about how we build that into a sort of transport-wide data offering. At the moment, we're not there, but that's definitely the intention.
And so that applies to the car occupancy and public transport data.
It applies to lots of things. So we have public transport data already in the department, and the recent bus open data service expands that, and we know lots of local authorities have it. We have lots of research work. We've been working with all kinds of companies to work out how we could do things like vehicle occupancy, and there's some very innovative technology coming to fruition in those areas. And I think as that does come to fruition, as that does become more mature, then yes, we will certainly look to see how we can. And the same as I said in the presentation, having developed a lot of really good stuff, a lot of really good new data sources and new technologies, new ways of working, we most certainly don't want to lose that for the long term.
And it's obviously generating an appetite for even more, which isn't surprising, really, is it?
Absolutely, yeah.
So, Philippe, just in case the question related to mobile phone network data, how is the multiple devices in vehicles accounted for? Is it something that can be used to monitor changes in occupancy?
Okay, so typically what we measure as part of our analysis would be person trips. We don't really go to the level of vehicles simply because of the behavior of devices. The important thing to understand is that mobile phone technology is not GPS in terms of actual precision. So that means that whilst we can deal globally with multiple phones or people carrying multiple phones, being able to say if two devices are exactly in the same vehicle is not really possible for us. If we've got two vehicles following each other or two devices in the same vehicle, they would appear to have very much the same behavior to us.
Okay, thank you. Darren, I'm bombarding you, but I'm just doing this for my own logic, if nothing else. So there were two questions regarding e-scooters, one from Mike Manchip and one from Adam Tarshis. Basically, I think getting to the same point of, there's an opportunity to capture e-scooter data, and that could potentially be a very rich source of data. Is that something that the DFT are looking to integrate into this data?
Yes. So e-scooter trials are something we've been planning for a while, and it was something that we had on intended to do in the next 2 or 3 years. And behind the e-scooter trials, there was a lot of work happening around data standardization. We're working with BSI. We're looking at things like MDS, the mobility data standard that's been pioneered in Los Angeles, and the implications that has, not just in terms of standards, but in terms of public expectations of data and data sharing. We're looking at NetX and European standards. There was a whole lot of work going that would have supported the e-scooter trials to do that. With the advent of COVID, e-scooter trials were one of the policy areas that ministers decided to accelerate, and it was felt that getting e-scooters on the street would be very useful in the very short term to help people commute and move around during COVID. So the e-scooter trials have come along very quickly, and actually the trials are now maybe running ahead of the research and policy work into data. But ultimately, the aim is absolutely that e-scooters, wider e-mobility, the move into more connected mobility will be delivered with a data strategy and a set of data standards around it. It's just the way things have been delivered because of what's happened this year means that's not quite happening. But absolutely, we fully understand the potential benefits of e-scooter data, the potential opportunities, and are working to ensure that as trials expand and as it becomes more business as usual, then the data frameworks and the data policies are there behind them.
And I can also add on, from our perspective, from Drax's perspective, we're aware that e-scooters are going to become an increasingly important mode of transport, and it needs to be one mode that is captured and identified and recognised, whether it's using artificial intelligence or video observation, whatever. So they are recognised as a up and coming mode of transport and will be integrated into future data sets. A question for Garode from Nathaniel Tan. Does Compass Informatics offer integration with CRM solutions through the private portal?
Yeah, well, I guess the important thing there is that particular portal is built around open technologies. It's cloud Azure hosted. It's a .NET built platform, so it's supporting all the standard approaches to integration. In terms of, I suppose it's important just to note what we're not doing is, well, in terms of the current configuration of Rate My Service, is capturing any personal data. Now that of course could be changed, it's a decision, but what we don't ask people to do, for example, is sort of log in and therefore and their password or the details around their device and so forth are shared up. So in terms of, that's the current configuration, that due to sort of the prioritization of data over the sort of personal tagging, we're not capturing anything, so we don't have that data to feed into, if you like, a CRM. But in terms of an actual integration to CRM or any other platform, yeah, that's available through, for example, REST services and so forth.
Okay, thank you. Thanks very much. A question for Graham from Gareth Bond. Will Conduit eventually include passenger count data at railway stations? That's obviously something that other parts of Traxys collect information on.
Yeah, so the Conduit system includes essentially any surveys that we undertake, but most importantly, it also has the information about surveys that are being undertaken that we haven't been commissioned to do. It will include passenger count surveys. I know that we've undertaken a few of them ourselves, and there will be others. So yeah, certainly.
Okay, that's good. Thank you. And Philippe. A question from Christopher Bucock. Do you have any plans or experience of undertaking mobile phone network data analysis in Europe? I know Europe can include Republic of Ireland as well, so I think I know the answer to this one. But But
so yeah, it's we have the ability to work with pretty much any area where we can get access to mobile network. So yes, we've done some work in Ireland, where also we've got the ability to work in Spain, to work in Italy, but even beyond the border of Europe. So for example, the Kuwait master plan, which was developed for the next 5 years, is actually based on mobile phone data from Kuwait, which we've analyzed to provide the underlying origin destination baseline data for the model.
And do we have the same sort of challenges regarding privacy? Are they mirrored in some countries more than others?
Yes, so actually it's a very good point. Whilst there are European standards, namely GDPR, we have the ability to work with these standards without any difficulty. However, some countries have even more stringent policies with regard to personal data. That, for example, includes Germany, where it is well known that you cannot follow an ID for a device, even if it is pseudo-anonymized, for more than 24 hours. That means we cannot do any what I would call longitudinal analysis over a long period of time. So whilst we can understand movements, some of the other informations which we try to infer, such as purpose, for example, reason for travel, is something that cannot really be generated for data in Germany. It's similar-ish in the Netherlands, actually.
Okay. I'm going to ask a general question, but first of all, just to wrap up on the questions I've received so far, Yangji, there's been a few questions about accessing the Tombolo URL. I think if we could follow it up through Landor with your preferred URL, and somebody's also commented about it not being HTTPS as well. So there's some kind of technical questions there that perhaps you could follow up through Landor after the presentation.
I can quickly answer that. I think the website, this audience identifies the project website. So that project website is basically like the first stage of the Web Tombolo project, where we develop the backend. And so the Tombolo tool I discussed in my presentation is sort of stage 2 of the project, where we have a front end that you can visualize the data. At the moment, that's it's been deployed to AWS, but it's only available for internal use. And if you are interested, feel free to contact me. I'm happy to share and find a way to share that project with you.
Okay, thank you. I was going to ask just some questions of each of the panelists, actually, about what you feel is the #1 challenge to your data discoverability, and in the instance of Connected Places Catapults, what's the biggest challenge to the initiatives that you help bring to the industry being taken up? What are the big breaks, and what could be released in order to progress people actually using the systems that Connected Places help produce?
I can speak for my own experience. I use a lot of data for project and for my own research. I think the #1 challenge is when you search all these open data portals, it's hard to find or identify the data that's most suitable to a problem. Either because when you key in a search keyword, you come up with dozens, if not hundreds, of available data. But it's not easy to quickly check, for example, the geospatial coverage, or the temporal coverage of the data, and also in general what the data quality looks like. So you have to manually download the data and use Excel or whatever Python package you have to look at the data. It all takes a lot of time. So we think there's a better way to actually integrate those kind of metrics, like what's the spatial coverage, temporal coverage, what's roughly the data quality looks like within the open data system. So anyone who wants to use the data can just look at them and visualize directly on map. They will save them a lot of time for their tasks. So I think that's the thing we're trying to do, make this process really easy, and also integrate some of the API capabilities. So make sure the data has unique data identifier with very good metadata to describe all the data attributes. So this is all machine readable. So you can really build up your data workflow automatically. In future, if you want to update your model, or if you want to update the data, you just basically rerun the script. It will automatically pull the data from the API, and yeah, save us a lot of time.
Okay.
Maybe to Paul.
Sorry.
Well, Paul, I could even just add to that, Garrod here. Really just that, really the risk with open data is that it essentially comes dumped data. So the adoption of data standards is so critical, really. I think an area that is greatly improving over the years, but there's not a whole lot of value, really. It's better than nothing, but there's not a whole lot of value in just spewing out data. I think that sort of anything to ease the adoption of data standards is critical, and we can see the value of that in our own work in terms of, again, well, to take the example of the Rate My Service, if you have a GTFS feed, it is close to sort of plug and play. Whereas if you're dealing with something which is quite proprietary, well, you have to do make additional effort to do custom work and so forth. Just work back into them.
Darren, a sort of question on sort of data standards, and I suppose linked with that, in this COVID-19 project, what has been the biggest challenge? Has it been the diversity of formats and quality and availability? What have been the biggest challenges for the COVID-19 data project?
I think data standards have been a big challenge. I think ultimately that maybe comes down to procurement and understanding business cases and ensuring that when people buy data, and I think certainly in local authorities, a lot of data is bought as a secondary consideration to a system. We buy a service or a system that generates data. That data is initially used within that system. So standardization is an issue. It becomes an issue when you want to extract that data and use it for other purposes. And we find too many authorities having to spend time hand formatting data, or us having to hand format data. So I think that the key is standardization. The key is having standards families in the various data sectors, and ensuring that when people specify and procure technologies and systems and services, they understand the standards that they should be specifying.
And I know that DFT has got the National Access Portal project on the go. Is that a key part of this process of moving towards standardization?
It is. So the National Access Point is very much and the National Access Point won't be us building a huge data warehouse. It'll be us building a way of cataloging and signposting where data is. So being able to specify data standards that people can expect to use when they use the National Access Point and access its resources are hugely important. We're also just about to produce a piece of work called the Connected Vehicle Data Strategy, which is about understanding the value of data that we will be getting very shortly, if not now, from connected vehicles. And again, part of this is to allow local authorities to think about the business case, think about why data, why investing in data, why investing in standards, why adding things to specifications that may increase the initial cost are worth doing, why there is a business case. And this focuses on 7 areas. It focuses on asset management, smart parking, pro-vehicle data, in-vehicle messaging, public transport, vulnerable road users, and signal phase and timing has been what we believe the key areas where there are solid business cases for better investment in data and better service delivery by the use of data and data standards.
Thank you. Philippe or Graham, would you like to add anything to those points?
I was just thinking with Darren's answer there, and just with regards to like standardization. Obviously, you've had a lot of data coming in recently, and it's all the different sort of standards that are there. And I think that's kind of what our aim with the Conduit platform is, to make it more discoverable. But as it is one of the first points of contact for surveys being undertaken, if we can keep it in a generic standard, if we agree a standard to keep that data in, then it's more than likely that you're going to receive it in the same way. And that's also, in a sense, why we're wanting to ask clients to look at bringing in third-party data from other companies, so that we can kind of standardize that in the same way.
Thank you. Philippe?
Yeah, I think from all of you, what's quite interesting on going back to the European example, what we find is actually the difficulty is actually the early stages where it's trying to gain access to the data, which is actually quite of a complex problem. It's mostly driven by policy on the actual frameworks that are in place for data sharing. On sometimes the fear that it might be too big brothery by some of the mobile operators, that fear that actually this might trigger a whole privacy issue, meaning that they are very careful in terms of sharing their data, which we partly understand. But considering the data is all anonymized, aggregated, and so on and so forth, and it's about understanding trend, not looking at individual people, we think it's actually using the data for the good rather than to understand personal things. Also, what's probably another point which I want to make is, whilst some of the data sets are purely designed for the purpose they are being used for, with mobile phone data, we've got something quite different. It's a byproduct, and I think I mentioned this earlier, meaning that there is a lot of analytics to take place on the data to infer the other elements that we are trying to generate, the mode, the purpose, the trip, and so on and so forth. That's a lot of analytics. They require a lot of skills. There is a lot of validation to be done on the data. And that's a critical element for us. And it should really be done by experts that really understand the data to make sure that you get the best value out of the data.
You seem to have lost connection very briefly there, Philippe. So you'll have to repeat that to me over a beer sometime.
Okay.
Well, that brings us to the close of the session. I'd like to thank all of our panelists, and I'd like to thank all of the participants. We had well over 100 people at the height of the session. The slides will be shared through Landor, and the session has been recorded. I think personally, as a closing comment, I think this story is only just beginning. It's great personally for somebody who's been involved in data and transport for nearly 30 years to finally see the importance of data being recognised and given due attention. So let's hope we can hear more reports back in due course about this data discoverability journey. So thank you very much, everybody, and I'll hand over to Landor to close the session down.
Thanks, Bob.
Well, thank you, everybody.